professor of political science and statistics, research professor in ISR, Center for Global Studies here. Probably pertinent for this workshop, I also have affiliations with the Michigan Institute for Data Science, called MIDAS, and also for the Michigan Institute for Computation and Data Engineering on a committee there. And so that brings me in contact with a lot of non-political scientists, and my stats department appointment also brings me with that. So I'm a political methodologist primarily, and I also have a lot of interest in elections. I have lots of projects. I've heard that Bayesian analysis is considered by NSF to be ML, machine learning, which I thought was weird because they wanted to exclude computer science from that same list, so that was a weird list. But anyway, I do some projects involving measurement, especially involving Bayes stuff. I've also got projects trying to measure election accuracy or frauds. That's sort of big data, but it's numerical data. I also have a project trying to race to get Twitter data before it goes bankrupt. I'm not sure. We'll see. I don't know if I'll finish by tomorrow. But we are trying to classify what I call election incidents, which is people's personal experiences from primarily text, but I also did a project to try to see if we could use multimodal data, text and images, to improve our classification. And so we have a paper with a former grad student published about that.
Hi, my name is Fariss. I'm an assistant professor in political science and faculty associate with the Center for Political Studies here at ISR. I think I'm also affiliated with MIDAS. Probably some other things. We have a lot of affiliations here. My research is primarily, I think, substantively focused. First off, I'm interested in human rights, political violence, and international conflict, primarily. Those things are hard to measure, hard to observe, and most of my work with computational tools has been with a focus on leveraging the different ways to creatively extract the information that we can access, and then try to understand the information, flawed or not, in an effort to understand those important concepts, human rights, political violence, and international conflict. Thanks for inviting me.
We're glad the four of you are here. Thanks so much. So we have a couple of questions that we'd like to guide this discussion, and we'd like it to be relatively free form. So feel free to jump in, build on each other's points. This should feel fairly organic. To start with, over the last decade and a half, the interaction between NLP, machine learning, and the social sciences have led to new directions in ethics, in data quality, and in methodology. So based on these developments, do you think that computational tools are reshaping social science research?
I thought first about sort of thinking about where computational tools come from that political scientists use. I think it's useful to think about the different places they come from because it shapes how useful they are and sort of what form they take. So one place they come from is sort of academic computer science research. And academic statistics research, sort of other fields that aren't political science, developing sort of new tools for academics, but with a focus on novel techniques. I think those have been very useful in political science, but they often need sort of a translation step to be useful for political scientists. And so I think a second place the tools come from is from political scientists who are often drawing on other fields like statistics or computer science, with a focus on sort of taking research that's in some sense academic and making it much more useful for applied political scientists to use. And the third place I think increasingly the tools are coming from is from industry, CS type industry or NLP industry. And I think part of that is because in some sense political scientists and industry have the same requirements from their tools, which is they need to be easy to use. You don't have to really get into the guts to change a lot of things or turn research code into something that works. You want tools that are basically functioning, not necessarily state of the art, but relatively easy to use. So I think each of those places have generated tools that are useful, and they all have their different advantages and applicability for political science.
Yeah, let me piggyback over those comments, which is, yeah, there's boring, and we have some people who are political scientists plus other fields. There are a bunch of people who are methodologists who are now as much statisticians as they are political scientists. They publish more in stats journals than poli-sci journals, or equally. People who are now doing more computer science in terms of learnings of various types. Some call it statistical learning, others call it machine learning, and there are nuanced differences in what those are, but the learning is the theme there. And that all has come into political science in a big way over the last decade or 15 years or so. And it has really gone with a great expansion in the range of data that people think are subject to essentially numerical models, but you can use numerical models with text as your raw data, and that's something that goes back to text is data. Organization and movement is one thing that brings a lot of folks together, both computer scientists, NLP, and other social sciences there. But there's other things besides text. So there's a group of folks who are looking at text and audio, for example, that have a strong presence in the profession and also beyond the profession. And so that's a big deal. The learning piece, and this is probably going to be more talked about when you talk about challenges for the field. This raises important methodological issues in terms of what are we doing with all these data. The bottom line is that in these other areas that Andy talked about, two features are there, which is one, computer scientists typically have taken the labels they get for supervised learning or just the interpretation of the materials they're processing as given. So you can read papers and they'll talk about the Oracle generated these labels and we're trying to learn the labels, and that's all taken as ground truth. Social scientists are not willing to do that actually, because we generate data and we know how hard it is, not only to train like undergrads or Amazon Turk folks, but it may just be inherently ambiguous what's going on there. And so handling that ambiguity is something that's not exactly been in the scope of what the originators of these learning methods have been focused on. This is a general, there's some exceptions, and there's a recent development that I'll talk about more later. But the other piece is that prediction is kind of the thing that those methods are based on. And that's mostly not what I grew up as a child in political science. I mean, I've been since the 70s, late 70s, I suppose, so I've been around a while. And you know, I was taught prediction was not what we were doing, absolutely. We don't inherently care. We care about interpretable models. We're trying to discover the structure of the world, and nowadays people are talking about causal inference, design-based causal inference, but they're still trying to make inferences about the particular design, random assignment mechanisms. Prediction is not really the point. And so there's some nuanced issues with whether prediction and inference about parameters, and my stats colleagues have that language for their distinction between these two things. There's a challenge to the field to think about which are we doing, and some bright young people have tried to fudge that and exploit that productively, but that's really interesting and a thing to do. So people can't just take stuff off the shelf and then replace what they're trying to do for a political science audience, because they have to address our issues there. Professionally, I'll say one little piece there. I've had a bunch of students over the past 5 to 10 years who have gotten dual PhDs, because you do that kind of thing here at Michigan, in both political science and scientific computing. And many of them have done, call them learning kind of topics, NLP, general learning. And also in the profession or in the economy, academic economy, there are a lot of data science jobs, computational social science jobs, and they have a list of fields they can do, but political scientists are really competitive for those because we're really good at doing these kind of things and thinking creatively through these application issues, and several of my students have gotten jobs exactly in those kinds of things. And so it's expanded our occupational horizons with some complexities about where you publish. And this has also raised the issue, and this is definitely something I'll talk about much more later, how do you publish interdisciplinarily across social science and, say, computer science fields, and that's a huge can of worms.
Yeah, so I definitely resonate a lot with this like prediction versus explanation or interpretation difference. That does seem to kind of be one of the biggest gaps. This might just be me as a student on the panel talking, but I don't actually know what makes something computational. And I think I realized this like when I took my first stats class, which was in the poli-sci department here, a little too far into my PhD. But it was all the same like models that I've learned Oh, in NLP, you train a logistic regression model. In statistics and Polcom, whatever, you fit a logit model. So the language around it is a little bit different, but it's the same thing, and I don't quite know what makes something distinctly computational, and I also, coming more from a computer science background, don't want to say that it's changed the social sciences, because that sounds really arrogant, and I don't know that. But I do think that one thing I've seen from people who firmly consider themselves within social sciences is having methods that can help with automated coding of data. So like more of the data labeling side. And yeah, I don't know if like the learning models or any of that is really substantially different than what's already been going on. But I do think being able to get labels for lots more data in a much cheaper way has been something I've at least seen a lot more in my view.
Okay, so one of your questions, very quick. When I took physics in high school, we used slide rules. That was not computational.
Thank you.
And actually, in our first roundtable at APSA, I think it was Noah Smith that said, oh, political scientists are better at statistics, but we don't do that. We do computational science. And he talks a little bit about the differences, and from what he says, it boils down to the scale and the speed more than anything else when it's applied to social science or questions that may be asked by the social science. But it was an interesting take there as well. So you're not the only one wondering.
I'm glad to hear that.
My short answer to the question is yes.
Would you like to elaborate?
But thinking through the short answer, it's hard for me to even imagine the counterfactual of what like my own personal experience would be in the field without the concurrent change in computational power that has sort of accompanied like my education. So I can think back to when I was a master's student and I had a big clunky desktop that sat on my desk, and then I transitioned to a laptop. And then I was fortunate enough that I had an advisor with a server that gave us access to, and I just learned a bunch about how to scale up models and how to make programming in R primarily, a little bit of C++, but mostly R, how to make that programming efficient. And then that was more than a decade ago, and now seeing the efficiency of a lot of the latent variable modeling short things I use. The first versions of those models took several weeks to run and converge, and now I can get similar models done in a few hours. And it's striking how rapidly the tools I take for granted have changed. And so yes, and I can't. It's hard for me to imagine what it would be like without that transition. And so I'm lucky that I was able to learn a lot of that stuff, and I had advisors who were willing to allow me to tinker with stuff that they didn't necessarily understand, but I had sort of hunches about. Those computational tools have been immensely important in the development of my, again, substantive work focusing on those important topics of human rights and violence.
Yeah, partly a joke to follow up on that. So when I went from high school to college, we progressed. I actually bought a hand calculator in high school, but the teacher wouldn't let us use them. But I got to college, and then we had computers. We had punch cards that we had to type and run. And it was great if you could get a interpreter punch card holder. So you got to the computer center, it was crowded. You had to type the punch card without being able to see what the letters were. So you had to memorize the pattern. So the progression of hardware and rapidity has been as much of a driver of this as has been development, as is in all these fields, as Chris mentioned. And so now I have what I used to consider a big computer in my basement. It has 256 gig of RAM and 64 cores, and that used to be a big computer. Now, not so much. And then you add GPUs and all the rest of it, so just the sheer availability of processing means that you can do all kinds of things that would take years and years and years, and you can never do it. Now I still have algorithms that take a long time because my computation expands to exceed the available computing ability. But it's just really enabled a lot of things to be done that could not physically be done in a human lifetime by anyone, let alone a grad student poli-sci.
May I ask a quick follow-up question based you think that has changed the way in which the research is done, or also the type of questions that are asked?
Both, right. You can just think of doing things you could never think of doing before. I mean, ask Chris about the range of data he's collected, everybody else here probably as well. Not only diversity of data, but just scale of data. I mean, back when I was a grad student, we were doing survey research, you think, oh, we have this survey with, 1,700 respondents.
Oh, that was a lot.
Very large data set. Really? And a few years ago, I thought, I haven't used data that are like multiple gigabytes, and now that's not even a big data set. So just the ability to not even think about really all these things, because you can, if you have enough money, I understand now why Jeff Bezos is a billionaire, because a little accident I had on Amazon, web services, but you can decide to rent these computers that occupy half of Colorado, whatever they are, just arbitrarily large data, and just run them, and then you have teams that can collaborate also, and this is the internet remote collaboration and everything, but you also need to collaborate with the experts that Andy was referring to in the field, and lots of organizations like the National Science Foundation have given impetus to do that kind of collaboration, and not only in universities, but across universities to exploit the skill, probably across countries and continents as well. Others probably have responses to that too. Chris?
Not to put
Or
you on
Andy?
the spot.
No,
but-
or Andy, I'm wondering, you both have experience with this.
Yeah, no, I mean, I think similar to Chris, like the things I work on only exist because of, I just essentially do computational techniques on text in a way that it wasn't possible even 15 years ago. And I think a lot of that is enabled by faster computing, but it's also, I think, better tools too. And I think this is sort of going back to what I was saying about industry too.
Mm-hmm.
That I think a lot of really, I use dependency parses a lot, so a way of putting in text and getting essentially a grammatical structure of the sentence out. So that's, like the development of that was purely academic, and it's computational linguistics, and wouldn't it be cool if we could do this? And then that research translated into industry, where people wrote these really fast, efficient tools to say, I can give you dependency parses for documents really, really quickly and really accurately. And so as a methodologist, a lot of what I do is translate sort of other research into a form that's useful for political science questions. But even so, it's, I'm not a computational linguist, and so 15 years ago it would have been hard for me to say, like, here's this Java code that does a dependency parse, I'm going to turn this into a tool. But because other people sort of working at the intersection of academic CS and industry have built these nice tools, that makes it a lot easier for me to say, like, I don't need to know how a dependency parse gets made. As long as it's good enough, I can take this and then combine it with some other tools and create a technique for extracting, say, information about political events from text. So again, part of that is enabled by faster computation, but part of it is also just better tools that are more efficient and easier for me to use.
Are there any thoughts on the follow-up? Otherwise, that's a good segue into another question we wanted to ask. Right, on we go. So Andy also made the nice point of like building on these sort of foundational tools that exist either from industry or from academic research to translate these into things that are useful for political science research. So what do each of you see as mismatches between some of these computational tools and the needs of carrying out social science research?
So very concretely, just based on like the communities these tools are designed for, it could be a pretty high barrier to entry for social scientists without like having taken many computer science courses in whatever education they've done. For example, a lot of tools are in Python, and a lot of people in social sciences use R or the other things that I've never even touched before, but
Or none.
if they're on this, yes, exactly, or none. I did introduce someone to topic modeling a few weeks ago, and it was amazing, and they were like mind blown, and it's just like like kind of a go-to tool in NLP of like, how do we understand the data? Let's run a topic model, and it was kind of enlightening. But yeah, if things are done in Python, if there are these packages that people use, it's just hard to get started with it. It's kind of like how people are trying to figure out Mastodon now instead of Twitter, like it's just like too much at once, and then it just stops people. I would say another mismatch, kind of maybe more foundationally, is issues with like validity or like just making sure that the things you're doing are correct. And I think that also has to do with different goals in different fields. So in computer science, it's totally fine if your model has 60% accuracy as long as the previous best model had below 60% accuracy. But that might not actually be sufficient, especially because that accuracy might be distributed across classes in some weird imbalanced way that biases all the results that you would do to answer social science research questions. So 60% might not be good enough because you're like, well, what's the other 40%? What are we actually really missing there? And like, how does that affect what we can say about the phenomenon? And from the computational side, it's better than before.
And then there is also the replicability that it's a big issue in social science, but it's much less of a big issue in computational science that I've seen that working on. So there is that as well.
And another thing to note with respect to the question of mismatch goes both ways. Because the computational and computer science folks aren't necessarily trained to ask social science questions and to do the hard research in answering those social science questions. So both sides offer useful information and methods for, approaches for combining the abilities on both sides. I've had a number of experiences over the years professionally in the academy, but also in industry where my role changed depending on who was in the audience. I'm a political science audience like this. I'm a computational person or a methods person. My identity is on the technical side. But then I've been in other scenarios where I was the least technically sophisticated person in the room, and suddenly I was a subject matter expert. But I think those interactions were really productive because I had enough insight about the computational tools to talk coherently, legibly to that community, and also provide the subject matter knowledge that was necessary for the conversation. Vice versa, in places where I'm definitely not the subject matter expert, for example, in human rights domains, I'm more the computational person. And so I think setting up those types of interactions where there's enough legibility by each participant so that the mismatches can be recognized and then addressed, in my experience, has been really difficult to address that issue.
Are you comfortable giving a specific example?
Yeah, so I study human rights and I interact with Amnesty International. And I'm usually always the most sophisticated person on the call. Not necessarily. More like one of the most, computationally. So, and then I've worked with Facebook a few times in prior years ago now, and there I was a subject matter expert. I was the least sophisticated person in most of those conversations in terms of my background in computational computer science.
I would just comment especially on, I share simply both what the previous speaker said on this question, and on the training issue as far as students go. This has been a big burden for many years. In political science, my political science department, which is my main department here, I took the responsibility for teaching the first year students the sort of pre-methods course called Political Science 599, for those who know what course I'm talking about. And for a long time, that was teaching a range of student experiences. Some students had a lot of experience with like statistical analysis, and some had a little bit or none. And we have a whole program to teach people enough math and all that kind of stuff. But around 10 or so years ago, it became obvious that all this learning, machine learning, computation stuff was going to be important. And so in addition to statistics and political science applications, we first had to deal with design-based causal inference as another thing, which has its own special things. But now, within a 14-week semester, you also have to teach them enough to do a little bit about understand what this computational stuff is. And happily, I stopped teaching that class around that time. I thought, I don't know how to do that. I mean, from the lasso to causal inference in one semester, because all this stuff appears in papers they're reading. And so the burden of it is really hard. We have another course which students are strongly encouraged to take, which is Introduction to Computing. And again, about, I don't know, 10 years ago by now, I wanted to turn that course into a programming course, not just how to use applications, like here's how you use LaTeX or something, but how do you write a program in some language. And some grad students who taught the course did it in R, others did it in Python. But my idea was once you learn one language, then you can learn a lot other, not every language, but a lot of other languages. I mean, I've got dozens of languages that I've learned over the years, enough to do some work in them. But students had a great experience with that, and recently I've heard feedback from students in our current classes that are really enthusiastic about the skills they're able to get access to, precisely what you said. A lot of applications are both Python and R, and so if you have some comfort in both, that's great, but if you know one, you can get to the other without too much effort, not no effort, and people have different skills, ability to learn that stuff. But that skill basis needed to be a successful social scientist is pretty high. And on Chris's point about what, say, the learning computer science, the NLP people do, this connects to the point I made earlier about oracles or not. Just recently I was at a talk where a learning person, actually a staff PhD alumni from my department here, was talking about learning and saying that there's, in the last 2 years really, a bunch of papers that are addressing this issue of measurement, is how I heard it. That's not what, they never used the word measurement, but that's how I heard it. Because they were questioning whether the labels are accurate. And I thought, well, that's a revolution. I gotta read more of these papers, because they never did that before. And my other thought was what Chris said, how do they know that? Because it's like they have a gut feeling. I mean, he and I deal with serious measurement issues, and it's not at all something you can just know what the right answer is. But they were saying things like the canonical data sets for image processing had some errors and things like that. So maybe you can tell it's not a cat, maybe you can do that intuitively. But for deeper measurement issues, it'd be really productive to have a collaboration, conversation involving social science, at least political science, I think is mainly about measurement as a methodological thing. It's a fundamental thing that we do almost uniquely among other sciences. Other social sciences do that a bit. And we know a lot of nuances about that. And the machine learning things are helpful for incorporating more data, but we need a collaborative effort to see what their techniques do and how we deal with prediction versus inference. But that idea that they're taking their serious skill sets and questioning these perfection in the, or naivete, I would say, about the labels they get, is a possibly really productive development. That if that's true that those 5 or 6 papers as I cited are opening a door to much of this being done, that could really be a way to expand the scope of collaboration productively between social science and computational stuff.
Yeah, I think just building on those last 2 comments, I think, so I've taught both political scientists and also in a data science master's program, and I was struck there at sort of the difference in how the 2 groups approach asking questions. Like so people like to say computer science is sort of all about like useful abstraction and sort of black boxes, and you don't really need to think about the details of what's going on in this box. It's useful abstraction to not have to reason about everything. And I was struck in the context of sort of asking substantive questions about the world. In some sense, how the social scientists are often better at that useful abstraction thing. Like, I have this text, I want some labels on it because I care about some causal question that I'm interested in answering. I want labels on these documents, and so I'll think about, it's like I need some sort of magic box that gives me the answers on this text. And a lot of social scientists don't really care about like SVMs versus random forest versus neural networks. Like it's not that very interesting to me, but not most people. And I think the data science students I taught were much more, their focus was, I want to use this cool tool. Now I need to go find a question that I can sort of put into this method that I want to make better. And I think both of those definitely have their places. You know, like I think we all benefit a lot from the work that computer scientists do, but it's hard to take that training of, I really want to understand how this thing works, and then try to use that to answer social science questions. It's sort of a different way of approaching the topic. I don't want to paint with too broad of a brush, because I think there are lots of computer scientists who are really good at moving back and forth, but it's hard to sort of switch the level of question from, I want to understand this tool and make it better, to I have a substantive question about real variables in the world that are hard to measure, and I need some computational tool to help me measure one of these variables.
So, I mean, at the first roundtable at APSA, Amber Boydston made the point, a lot like what Julie was saying, about like computer science has very much become this field of methods, and you care a lot about if your accuracy is 37.5 versus 36.5. This is a big deal to a computer scientist, but as Julie was saying, you've got this nuance of like, how is that improvement actually distributed? So if you've got either like these ambiguous labels, or you've got some nuance in what you're trying to annotate, whether it's something more fine-grained than like sentiment analysis, or it's something, you know, actually complicated to grasp for these models, like sarcasm and humor, then these are places where the computational tools that we have available today don't really meet the needs. Are there other places that you've seen like this sort of either deficiency or this stylistic mismatch beyond the questions of prediction versus interpretation and inference? Things that you would really like to be able to either annotate or infer quickly using computational methods, but they're just not there yet.
What I heard Julie saying was that the standard that she was referring to in computer science is not sufficient for social science or any substantive science, it seems to me, because we have what are you missing? Because again, 60% might be perfect, might be great, that may be fantastic. And the way I was brought up, we don't really care about predictive accuracy in the first place, we care about other things.
Right.
And so you can't throw those away and just decide to do that. I heard the sarcasm thing I think it was the first one you said, I saw it on video, and we had to deal with that when we were labeling tweets from the 2016 election, and we were wondering whether tweets were, to be very terse here, supporting the two presidential candidates from the major parties. And of course, that way you could say if they mention Hillary Clinton, they're supporting Clinton. Okay, well, as they say, crooked Hillary, right? That was a big thing people said at the time, and there's other adjectives you can put in front of the various candidates so you can easily think of what they would say that are not really, we call them hostile references. And so Patrick Wu, who's now was PhD here and is now a postdoc at NYU, we focused hard on this, and we developed a method of actually borrowing a couple of papers we found in the literature, of actually labeling these references in the text for their hostility, or that's one word I would use here. And then we did a separate classifier step to classify the hostile instances, and then labeled from the classifier the hostile instances, and then used that to classify the things we were actually interested in. And it turned out to work, as we managed to exceed slightly the performance of the classifiers in the papers we were citing. And again, we had like 0.57 and they had 0.55. So in that sense, we were better than them. But those are not actual numbers, we were actually slightly better than that. But that was the way we dealt with the sarcasm thing. I think here's an issue of the black box comment. You really just can't expect to point to the box and have it solve all your problems.
Yeah.
It's not automatic in that sense. And so but you can bring to the device other infrastructure, other work, other knowledge, and do things to exploit what the black boxes, which actually shouldn't be treated as black boxes, these predictive algorithms, what they can do, they can help a lot with these kinds of things. And so being aware of like the sarcasm issue, and I don't know what the way we did it will work for everybody, but they were actually doing irony, I think, in their label, we were doing hostility, the prior literature. But I don't think those are fundamental barriers at all. It's just a question of knowing what you're interested in and knowing enough about the methods to be able to do these adaptations.
I think this relates back to the second question about the one way I try to address this issue with teaching with mostly, almost exclusively social science students, undergraduates and graduates. The core goal in all those classes is, the pithy short version of the goal is learn to program, program to learn. And what I mean by that is, if I can get my students comfortable enough, usually in R, to be able to use some basic programming structures, to understand how to simulate some data, add in some random numbers to the data generating process. You can use those tools to then figure out how any kind of algorithm or computational model works. And I try to get them to the point where they can break down large-scale, complicated algorithms like a neural net, a latent variable model, anything like that. Break it down into little pieces, so to understand how those little pieces work, and then they can feel more confident using the tool or modifying the tool when they apply it to the social science data. My hope is that once that comfort, once a certain level of comfort is reached, they'll feel comfortable using those tools to address these social science issues that we've been talking about, the mismatch between what the labels say, what the labels are, and what the actual content means. So that's how I try to address it. And that's how I think myself, but then also how I try to train my students.
I want to go back to Julia's comment about sort of the leaderboard focus. And I think my experience in sort of as a political methodologist is, if I have a choice between like the absolute state-of-the-art model on, say, something like named entity recognition, but it's going to take me like a week to figure out how this research code works and the runtime is 10 times as long, or there's another model that's, maybe 2 points worse, like a pretty big difference in terms of CS, but as far as my use, maybe not that big of a difference. And it's like ready to go and efficient, and the code is nice, and I'll be able to understand how to work with it. I think my preference is almost always for tools that are sort of easier to use and require less investment, and I'm willing to pay some time, some cost in performance maybe for that sort of usefulness.
What you're saying relates to something that, again, in the first roundtable, Justin Gross said that there is little appreciation for the small increments in the social science. You just want to see whether it works or it doesn't, and it's somehow able to give you a sense whether the question works or doesn't. Whereas in computational methods, that small increments, it's really what you are trying to look for, to see whether it works better.
And we definitely benefit from the sort of the leaderboard chase.
But it's not really useful when we ask the question, right?
It's you sort of want to be a year or two behind. Sort of taking a tool that's not absolutely state of the art, but is mature enough to not have to dig into someone's research code to figure out how to make it work.
I think part of what's implicit in what Andy is saying is, if you write a paper, we have these things called reviewers who have to understand the paper. It's going to get published, and you're trying to get published in a top-level science journal. Maybe you're lucky if one of your reviewers is a methods person, maybe two, but there's the Plato scholar reading your paper. I just cite the person who's farthest away from data and everything else. Plato scholars that I know are really great people. But the methods have to be intelligible and explicable well enough, and in fact, they generally don't care about the details like that. They don't. You work all these years to invent this stuff and develop it, and sadly, no one cares you put all that effort in. It's what is the payoff substantively? And the problems of social science, at least political science wants to know, we are not even close where tiny refinements are the thing that's going on. We're just trying to learn what's going on at all and try to find pots of data that can be applied to understand these things, either just in pure description, which I think is still worthwhile, or to design causal inference opportunities, or I guess that's really the range of things that are in play right now for empirical analysis. So we're not really, the errors are much bigger in a different category than, we're at the final end, we're talking not only about the cathedral and the gargoyles on the cathedral and what color is the paint, no, we're not. We want to know, is there a cathedral?
Yeah.
What is the cathedral?
Can we see?
Can we see, exactly, right. So we're well down the road, in the wrong way.
One of the points was, Julia, you were saying that like topic modeling is like a go-to approach that computational people take, right? It's kind of the bread and butter. And I would say part of the reason for that might line up well with the fact that the tools there are mature. There's a really widespread toolkit called Mala for topic modeling, and it's not state-of-the-art in the sense that it gets you, best performance on whatever external measure, but it's state-of-the-art in that it is approachable, accessible, and battle-tested. So is it fair to say that that's part of where this is coming from, is the confluence of your remarks?
Yeah, I think what methodologists do is try to pioneer new techniques, but the vast majority of political scientists, they want to use a tool that works and that other people have used before them, and where there's a nice paper where they can say, like, if you don't like the tool, here's a paper that sort of justifies the use of this. And so for topic modeling, I think that's really STM in political science, because it's a very nice package. It's very easy to use. Thousands of people have used it. It's pretty well accepted, and so maybe people will take sort of a philosophical objection using a topic model in your text, but no one's going to get upset that you're using STM to do topic modeling. So I think there's sort of if you're not a methodologist, you don't necessarily want to be on the absolute bleeding edge of some new method, because it takes a lot of work to justify the use of a new technique in political science.
Well, and it might not pay off. That's also the other. You want to use the shiny thing when enough people know that it's shiny.
So another question that we would want to ask the four of you is big data somehow the reason for these mismatches between the social science needs and the computational tools? We've talked about the growing scale of computation. We've talked about the growing scale of data. So
could you, I was curious about that question. Could you define one or more big data definitions?
that's always tricky, isn't it?
So you could answer the good one and the bad one.
More than 7.
Yeah, and a little bit, you can build on something that was said before, that the data sometimes drives the question much more than the other way around, and whether it's true that there is really not an accepted sequence of how you go, because sometimes you find out things as you're looking at the data. Over the past decade and a half, the simple fact that you have access to larger data set, which is labeled big data, whatever it's in there then is up to us to discover whether it's anything good or bad and in the middle, may be one of the issues of these mismatches, the over-eagerness of social scientists to look at things that maybe the tools are not able to.
So I take the definition as data sets that are large, already, by definition, already digitized, and usually unknown, or there's some level of ambiguity about what the data set provides. I think it's true we are getting access to more and more large-scale unstructured data sets to which the meaning that we would like to pull out or understand is not we're not designing the survey or test or data generating process ourselves as the analyst or the experiment. Rather, we're taking some large, complicated social system and the information that comes from it, and then trying to understand it. So I think that's what I think most people mean when they say big data. It's this large, unstructured data set that we can use computational tools to explore, and then maybe find insights from. But we know it's easy to find patterns in large-scale data sets that may or may not be real. I think that's the key challenge. I think that's where, in political science at least, there is some people are uncomfortable with the use of those large-scale data sets because there's a big concern about finding patterns that aren't meaningful patterns when we explore those large data sets.
I just had a couple of other possible definitions of big data, or aspects of it, to what Chris was talking about, which is diverse data, and also rapidly high velocity data. And diverse data, I already talked a little bit about how we have diverse modes of data coming under control, where you have a core numerically expressed data generating model, to use that terminology, and you can easily relate that to many manifestations of that data, from text to numbers to images to audio, and political scientists are working on all of those and combinations of those. So I think those are opportunities. The giant scale of the data, often leads to the thought, ooh, I don't have a computer big enough, but we have this thing called statistical sampling, and so you can always at least do pilot work by just taking a random sample, maybe just a simple random sample, to cut down the data, and you're gonna be pretty good in your finite population inferences. Humans are a little challenging, but it's just a big pile of data. You can easily do that, and that's a nice way to not mean you have to rent half of Colorado to do your analysis. At the end, maybe the reviewers will make you do that, but then you don't have to worry about that for doing the real science. It's just R3. God, okay, so, but the other issue about rapidity of data, I don't think we're quite there yet, because I've been concerned for a long time of this talk about the Internet of Things coming along. And we'll have signals from absolutely everything. And so eventually we'll have all the Alexa statements and all the monitoring of Alexa things that come. Amazon keeps all those data secret, and as far as I know, you have to work for Amazon to get those. But that's the thing I was wondering about. This is a complexity, rapidity, diversity, uninterpretability. It has all of those challenges. And on the one hand, it'd be fantastic at data at that scale of observation, meaning small, detailed observations and large. But our social science theories, or these political science theories at least, are these pathetic little theories that have like 4 or 5 variables, and you have A and B cause C, and no, the world is not like that at all. And so there are many other ways of thinking about ways to express models. And so, but I think we're not there yet. I don't think we're the easy availability of such things to routine researchers, or even very endowed researchers at big universities with lots of money and lots of grants. We're not quite there yet. And so the lack of ideas we have to handle such data will be a real problem, because we lack ideas to handle such data. But when they become available, I think really smart people with good resources will step up and improve our ability to study things a lot. Whether we'll be successful depends on whether the world is actually understandable at that level. And I don't know, because we haven't done it.
Yeah, I think, yes, like what you said, the big data we have now is still not all the data ever. And I actually do think that leads to, I don't quite know if it leads to mismatches. I don't want to blame the data itself, but given that, say for social media, we have these giant corpora, we can, until whenever, collect tweets from APIs. We can access some signals, but not all of these signals. And for me, for example, I want to know, so I see people have these tweets, I can maybe get what people like, who they follow, but I don't know who these people are. And I can infer that, but that's like super shady and unethical, so I don't want to make inferences about who people are based on their activity. I want to know what types of news people are exposed to online, and these types of things you just can't get with the big data that we have, because it's still not everything, and to try to make it everything, it gets into like very hairy territory I don't want to really touch. So yeah, and I think that does sort of become an issue when the research questions and the methods are shaped by the fact that we have access to some of these big data signals, but not all of them.
Yeah, some of what you want to know is very old-fashioned survey data.
Yes.
So the demographics, which is what we want to look at.
I'm in Michigan. I resent your comment about survey data being old-fashioned.
Oh, no.
but just to
No, it's what actually I have been trained in.
Yeah, exactly. But to piggyback on what Julie said, I mean, give an example. I teach a course called Election Forensics, and there's a couple of papers that came out recently. We'll use cell phone data to monitor folks to see whether they were at a polling place or not. And so when I gave my students last year this paper, and their first reaction was they were completely freaked out.
Yeah.
They thought, what? They have like, hundreds of millions of cell phones, and they can follow exactly where they were, and I've had the opportunity to work on such data, and I kind of said, I'm creeped out. I'm with Julia here. I don't really want to go there, but I know my other colleagues are not deterred from that. I think there were a couple of political scientists in one or two of these papers, but they were freaked out at the fact that that level of observation was available. Because there are polling places, we can follow those home and see, and you can do everything with these data.
But building on that, during the pandemic, that sort of like Google opened some of the data related
Yeah.
to cell phone movements. It's some of the best data ever to see whether the lockdowns were, or the limited mobility suggestions and encouragement were actually effective. And there is a very interesting paper that shows that when, I don't remember where, but the only places you could go were pretty much the supermarkets and sort of like CVS, the number of trips that people were taking was much higher than normal because it was a way for them to go out. And these were data that are out there. They just simply go where your phone goes. So, but the value also on that, it would be fantastic to use it as panel data. That very often it's the most expensive way to monitor over time. Whereas if we find a nice way to be able to measure what we want, big data is panel data all around.
The trick though is if I'm using such data, my first temptation is, surely I can cross-reference these anonymized data with some, well, take the phone book, for example. I'll just figure out who they live, because cell phones was most of the time at the place where the person lives. So if that's where they spend 12 hours, we know that's where they live, and so we can just match all the names to that, and it's only, I think I'm not really sure whether all IRB boards and would stand up against that research, or people may do it and ask for forgiveness, not permission. So it's a really, among industry, they do this all the time because they don't really care. They want to make money, but academics, the temptation is so strong. Just think of all the covariates you could bring in if you knew who they were.
So this brings up another challenge for big data analysis that we're talking about, and that's people eventually learn that they're being tracked, and individuals are strategic, and some respond by changing their settings, and signals change, signals go away. During the Black Lives Matter protest, people were being advised to turn off their phones, and either leave their phones away. And so people are in these social systems that generate big data that we can then analyze, but they have intuitions or hunches about how they should and shouldn't behave. And there's variation in those hunches, and that's something we can't observe directly. But we need to be thinking about those strategic decisions that the individuals, or generating processes that are observed, how to, like we need theories about those social behaviors too. And because the systems are changing so rapidly, Facebook was like a kid's thing 15 years ago. Now it's not a kid's thing. Most of my students aren't on it anymore. They're on TikTok. None of us, I don't know anyone here that's on TikTok. I'm not. I don't understand it. I mean, I've tried to, but even that platform's, my understanding is it's rapidly changing the memes and the content that are used and consumed by the individuals that are embedded in that. Twitter might go away, in a few days, and we might all be on a different system. I'm not sure. And that's, our behaviors are changing because of the way these systems are changing, because of our understanding of those systems. So that's a big challenge theoretically for all of us social scientists. And that's, again, back to the mismatch with computer scientists. I don't know if we're thinking about that necessarily.
It's still the Hawthorne effect. Still the Hawthorne effect. Big data. So people realize they're being watched and then they're behaving differently.
Oh, yeah, well, I can,
Pondering.
well, maybe I have one more definition of big data to use. Sorry, Julia. So I think if you think about big data as data that you can't fit on one machine, I think there are relatively few data sets like that we have access to. So I think there are some things like call data records that occasionally people get access to that, if you're doing certain kinds of things like network analysis on call data records, like just because of the way that those matrices are, it's hard to fit them in memory sometimes. You need different techniques, but I would say for the most part, the limitation is our access to big data as opposed to our ability to process big data.
I
Yeah, I mean,
go to half of
I've done projects on like, maybe half a terabyte of text, and it's relatively easy to just, it's parallelizable. You just load it to memory, process it, store it somehow. And I think for a lot of computational, like ML type flavored computational analysis in political science, basically we have some complicated data like text or video or images or some kind of multimodal data. And for most political scientists, at the end of the day, we want it in something like a CSV, so we can put it into something like a regression, and or a measurement model, like some variant on a regression. And it's relatively easy to parallelize the process of taking the complicated data and turning it into something that's very distilled and easy to analyze.
Sandy, one of your experiences kind of like mine, which is, I started out with the tiny computers and tiny data sets, and then by orders of magnitude, the number of observations and variables increase, and then it's power, squares, and other. But the first time you encounter a 2 terabyte data set, it's a huge shock. You have no idea how to handle it. You do all these things to build an environment. The next time you encounter a 2 terabyte data set, it's no big deal, and so your next threshold is 20 terabytes or 200 terabytes. So you get accustomed to and learn how to handle these bigger and bigger data sets. So I think it's a evolution, and then of course, at least for me, I'd love to have bigger data sets, because now I can handle these, so because of the richness of the data. Is that kind of matching your experience with text or other kinds of data?
Yeah, I think it goes back to what you were saying about, a lot of times we care about basically 5-ish variables.
Yeah.
And so we don't need the full text. We don't need to like take every single document and put it into one big model. We usually want, like say for my research, I have a terabyte of text, and I want basically one entry for every protest described in the text. And so I can just iterate over the documents, pull out protests, and then I have a CSV that's maybe a gigabyte or something, and that's quite easy to work with.
So a lot of this then does come from changes in the scale of the data. So how do current approaches to addressing then these mismatches between the computational tools and social science needs either succeed or fail or even miss the point?
Putting my methodology hat on, I'd say it's what we look for as methodologists. We look for challenges and here I'll call them triage or arbitrage opportunities, and that's what we get the big bucks for. If we get big bucks as academic salaries, is we solve them. We solve them, and so these are opportunities from my point of view. For people who just want to take the tools and run with the black box, they may think, oh my God, it doesn't work. But for me, it's like my eyes get big, and I'm looking for students who want to work on that stuff and try to figure out how to do it. It's fantastically exciting and opportunistic for development, in my point of view.
Yeah, I would say like from my experience, scale is maybe one of the smallest challenges. It's most of speaking of text, most of the text data sets that I have access to just like aren't really that big. So even if it's 100 gigabytes, it's not that big of a deal to just iterate over them. I think that the much bigger challenge is things like, you talk to someone who's just like, oh, I really want the ability to attribute quotes to people because I have some interesting political communication theory. How do I do that? And then say, okay, well the challenge is we have these models that sort of work, but we don't really know, and we need to take those and apply them to the question, turn it into a usable tool. And then if it takes like an hour to run versus 6 hours to run, once it's all working, like it's not that big of a deal.
Yeah, I agree that the data set sizes are of secondary importance. Because usually you wait around a few years, and social scientists are good at waiting around a few years because all the other things you have to do besides the data analysis takes time. I look back 10 or 15 years and what I'm doing now wasn't possible. And so, the new opportunities arise as a lot of the computer science and hardware problems are addressed elsewhere. And so, what that means for me is just that there are new opportunities that I didn't have before with similar data sets. For example, in the human rights community of scholars, the primary data that we use is a corpus of documents published annually by the State Department, Amnesty International, and Human Rights Watch. And we've been using those documents since the early 80s. For first it was, by reading them and having students learn to categorize the information. And a decade ago, we started getting it all digitized. Now we have it parsed out at the sentence level. And we've got a bunch of sentences classified for the content in them. As the tools have progressed, we've been able to do lots and lots of more nuanced things with the information embedded in those reports. But it's the same data set we've been using for 30 years. We're just able to process and analyze it more and more interesting and sophisticated ways. But ultimately, we're still hoping to take the inferences that we get from the tools that we're using today and derive scientifically valid meaning from it that's related to what we already understand about what those human rights documents say. Again, which is an imperfect representation of what's actually happening in the world with respect to human rights.
So if scale then is not the primary issue, it's a secondary one, what is the primary issue?
I think deriving scientific meaning from the information.
Okay. So it's sort of like the prediction versus inference and explanation and interpretation point that's been brought up a few times. Would you say that?
Well, I think I'd say because good social science is question driven, although as a methodologist, I sort of have to opt out sometimes. But because good scientific inference and research in political science is substantive, I think a lot of what we do is we have some specific need for some kind of measurement that other people haven't done before because we have a different question or a different approach to the question. And a lot of it is figuring out how to take all the tools we have from stats and political science and computer science and put them together in a way that allows us to get the specific measurement that we want to answer our question. So a lot of this is it's these kind of custom measurement or information extraction techniques that other people haven't done because they aren't asking the same questions as us and figuring out how to build those tools and make them available for other people to use.
Is it then that they're building the wrong tools, or is it just that the pieces are too foundational and you need to like build a layer on top of them?
I mean, I think most political scientists aren't interested in building tools because that's not what they do. And so I think that the role for methodologists is we talk to our substantive colleagues, we figure out the problems they have, we sort of have a sense of what's out there. Can I build a tool that solves this data problem? And then we build the tool and co-author with them, or they use the tool. And I think it's more that it takes a lot of work to both identify the real question or problem, which is often quite specific or niche, and then build the tool. And the people who have the questions aren't always the people who build the tools, and so I think that's where a lot of really fruitful collaboration happens between methodologists and substantive researchers.
It's a little bit Katada when David Beaman was saying, like, once I was having a casual conversation with a political scientist and said, well, we cannot really measure that, but we can give you a sense of what is bias. And the politics, you can measure bias, which is one of the most complicated things to do. And again, what exactly are you measuring within bias? So it comes back to that.
I wouldn't say the tools fail, because even if you have a successful tool to solve the problem that's been well formulated in the way that Andy was saying, that's great, but we're not going to retire. There's so many, you learn what other questions you want to follow up with. Or, okay, I've done this part, but now the part I didn't do because it's hard, let me do a small progressive thing on that. And then there's some progressive steps. Then someone has a very different idea and it changes. So it's, progress in science is a series of reputations, sadly. I could say standing on the social of giants, but it's not all, sometimes it's fights between your method is terrible and lots of people are using it and there are takedown papers like that, but usually it's not like that because there's so many difficulties doing social science research that no one expects any piece of work to be perfect. And we just learn more and then do different things because we learn more and get more opportunities because of, now the data digitized, that's great, I don't have to resort to OCR myself, which I've had to do a few times. And so I think it's not negative, it's progressive, that there's a continuing need and opportunity for more of these to be invented and tested and convince people that it works as the way it does and its limitations, whatever it is.
Yeah, I agree with that. So like the theme of this panel being mismatches between the computational tools and social science needs. Like, yes, there are mismatches, but that's like how I want to get it job after this. And no longer to not be mismatches. So like, I'm okay with that.
Well, it can be an opportunity to find out things or asking questions that we were not thinking about. So.
Having thought through this and talked through this on the panel, it seems to me now that the mismatch is maybe in the moment cross-sectionally a challenge or a problem, but temporally it's a feature of the interrelationship between these different fields within academia and elsewhere. And there are opportunities that come from the mismatch that we can take advantage of either as substantively focused scholars and methodologically focused scholars as firms out in industry.
I guess part of my difficulty with that is if you've got these sort of separate silos that eventually need to talk to each other in order to make progress in building toward being able to answer some of these questions, like are there certain things that people who swing even more on the computational end of the spectrum you wish they either understood or knew in advance in your conversations with them?
Not necessarily, but I would say I think the challenge is there seems to me to be here, because of this panel, increasing opportunities to talk across the silos, and so hopefully the boundaries are continuing to loosen. I think that's probably the biggest challenge. I'd rather have an opportunity to talk with a computational person and see what they think, and they can see what I think. But those opportunities still are rare because, not rare, but less frequent than might be best for addressing this mismatch as you defined it. So the more conversations like this, probably the better for addressing that mismatch.
I would say even going beyond conversations like this, I mean, as I mentioned earlier, and as everybody knows, the National Science Foundation, just a source of research funding a lot, is really pushing for interdisciplinary collaborations, and especially from the CS side, because they've got a ton of money in the CS NSF, they really are looking for collaborative with subject matter specialists, is the language that Chris used. But diverse teams are better than homogeneous teams in general. And so we don't want the learning, computer science, whatever experts to know what we know. We want to be able to communicate a bit. And so part of it's the barriers Julia mentioned a long time ago of softmax. What? Oh, that's just logistic. So there's this terminological barrier to get over, but that's pretty easy to do once you do this translation. Oh, I'm in machine learning now, so all these words mean this, that. That's pretty easy to do. But then there's the issues at the lower level. But then if you have a concrete project that you're working on, then usually you don't solve it in general. You solve it in order to get your paper, book, program, whatever you're doing in this, in your joint project done, and you build up a set of understandings there, and they go off and deal with their students and so forth with the refinements they see. We do the same, and everyone comes back. And I think that productive environment is the thing that's the result. Not everybody knowing everybody else's specialties, which is never going to happen anyway. And then we get to the issues of what are barriers to that, and has to do with the different publication standards and all that. But many people have found ways to get around that even, but that's, I think, the main barrier to a lot of folks.
This brings us to the next and our closing question, what we label as the city of failures. Given all that we've been talking about and the difficulties to work across the two fields, what are your experiences of successful, not successful, and is there a lesson in any of that? Run away now or later?
So first off, are people in the audience familiar with the concept of a CV of failures?
No?
Okay.
Okay.
Excellent. All right, so there was this researcher, I think in Germany, right? And he put on his website a list of the fellowships he didn't get, the programs he was rejected from, and even at the top of this was this meta failure that his CV of failures had actually garnered more recognition and visibility than any of his actual academic research.
And he started from, he wanted to make a point with the students that your CV, the traditional one, is just you only list one thing that is the positive thing, right? But your experience comes from a lot of other things that are equally relevant. And so in his classes, I think that he is originally an economist that did something in sociology or vice versa. In all his classes, he asked the students to prepare a CV of failures because there is value in any case. So that's what it is. If you guys Google it, it's a lot of fun.
So here what we're trying to ask is about, I guess, the failures or the challenges working in this this intersection, working with substantive people, working with methodological people, computational people.
Publishing across.
Exactly. Things that either you had wished had turned out differently, things that you learned from the experiences along the way, either about how to do this style of work, how to publish in these venues, or how research itself should be done.
Well, I mean, not in the machine learning, computational learning area, but about 10 years ago or so, I was trying to collaborate with some computer scientists in the area of election security, election administration kind of things. And I was invited to join a large project that had NSF support, and then we applied for another grant. And I don't think we got the second grant that I was part of at one too, but that led to an initiative inside a computer science organization to have conferences with publications. And so at that time, social science departments didn't really credit conference papers or conference proceedings as much as maybe some do now. And so we thought we'd do a journal and the conference, and so sort of satisfy both worlds, the political science types and the computer science types. And it didn't work because, I don't know, at least from the social political science side, my political science colleagues just couldn't find a way to understand what this was about. They didn't understand what, an 8-page paper with no theory? I mean, that's not really what we do. And so when they were reviewers on these papers, they would read them as if they're political science papers, and of course, they were terrible as political science papers. And the computer scientists got irritated because what are all these questions? I mean, that's not what we do here. So the rapidity of computer science publication goes from the rapidity of computer science publications from political science view looks like, well, of course, because you're not even writing a paper. This isn't even abstract. And so it really didn't work. So political scientists they stopped joining, they stopped participating, and the reviews were bad, so computer scientists got driven away. And the meeting at that time and the expertise you need for election security, election administration is generally multidisciplinary for maybe obvious reasons. And I'm not sure anyone has found a solution to that now. I think there's still conferences where you can go and present this kind of stuff, but you know, cryptographers and the election administration people are just in very political administration, political science, and the others like computer science and cryptography. So that really destroyed that, or that particular initiative didn't work out in the way that I want. Since then, I've had grad students who have gone to like AAAI and other and just written computer science papers or artificial intelligence papers or NLP papers and just presented there. And then they have to write political science papers, and on the market, their experience is diverse with how well those conference proceedings are received. I guess in most cases, it's not really the best investment if you want a political science job to present at AAAI. Let's put it that way.
I do run into that issue presently a lot, where I have only pretty much published in conference proceedings, and as a PhD student, there's one option is like there are many deadlines every year, there are many conferences every year. It's a very, very fast cycle. It's 8 pages. You can do at least like one a year. That's not how political science journal articles work, to the best of my knowledge. It's a much longer process. Each contribution is way more substantial. So basically, because I am like kind of short-sighted, I do the conference proceedings every single time. And that will also shape like, when I go on the job market, where can I look? So I think the incentives there are a little bit weird. And I will also say, the computer science paper from a political science perspective would look really bad. But I've had issues where, so I submit in computer science venues, and they even have computational social science tracks. But yet, I will have at least one review that's like a weak reject or borderline score every single time, which is something about the method being not novel enough or results are unsurprising. And I don't know why they want results to be surprising, especially with the things I'm working on. I'm like, I'm sorry that you already knew that Republicans didn't like immigration. Like, I'm sorry. Like, so I think there is that issue, like, where they want some sort of like, some notion of methodological novelty, even if it is in some ways, or some people would consider it novel, and also this element of surprise that I don't think is really considered in other places, and I don't know what they mean, but I have gotten that feedback many times from computer science vendors.
We have to. Same thing, like, oh, okay, it's only incremental. Well, okay.
Yeah, exactly.
A favorite review of a paper is like the first time we submitted it. We got 2 different reviews on an 8-page conference paper. One of them saying, well, this is great, but you're talking a lot about social science things that maybe you could put all of that into the appendix to talk more about the actual methods involved here. And reviewer 2 said, well, this is great, you talk a lot about the methods here, but maybe that should go into the appendix so you can talk more about the social science. So this is something that I also ran into back when I published in psycholinguistics, which is the expectations aren't really clear because it's at this sort of confluence. Is that things that the rest of you will also run into?
Well, so I had a failure, but a little bit different than that. So it was a big NSF project with a bunch of computer scientists, a bunch of political scientists. It's maybe 6 or 7 years ago. And because the political scientists went to the computer scientists, were like, this is great, you can write all of our code for us. Like, we want these nice, easy to use tools that political scientists can use. And like, we're not software engineers, we need to publish novel computer science research, so that's not really what we do. And then they would come to us and say, like, we want a challenge data set where we can like run our method and get the baseline and then beat it with our new method. Like, we're not really in the business of making like benchmark data sets. Like, we have to have some theories and stuff. So I think that was a very clear case where we both wanted the other group for very instrumental reasons, and things we wanted them to do, they had no career incentives to provide. So I think for collaborations like that, it's really important to keep in mind what each side actually has to do sort of for professional incentives. And I think some of that work is maybe work that's best outsourced in a paid way to a consultant. Like, I need someone who's going to write this. It's like a nice piece of software that's like a nice library that people can use that encapsulates our research, but computer scientists that's not their job to do.
I do keep track of some of this stuff, mostly for my own records, but not even at the intersection of these fields, but just within political science, early in my career, or especially early in my career, there was just a lot of uncomfortable reviewers who were uncomfortable with the tools I was proposing to use. And they were fully presented in a 10,000 word political science structured article. And sometimes in the same round of reviews, sometimes in the next journal, just completely different takes on whether the method was good, it was terrible, it was great, it wasn't just the series of rejections on some of those early papers I worked on, it was the total randomness of the disagreement between the different reviewers. They just all had different takes. And so many of those early papers just got rejected a lot. And fortunately, I was either stubborn or persevered, or whatever the attribute was, and just kept would try to refine it and submit it. And I think now, even with rejections, within political science, in the standard political science form, I think that the multidimensionality of the reviews has sort of this collapsed to something that's a little bit more manageable. So I think that's a useful change over the last decade that I've seen. One other failure I was going to mention was, I don't know if it was a failure. There was this brief window when I was in grad school where my friends with the lead data scientist at Facebook. And we got to work with Facebook and their data for about 2 years. And that window closed pretty rapidly in 2012. Because when we started, the company wasn't public, and then it was, and there was just like, now there's no way you would let people publish with their data. Just for obviously the political setting that we now reside in has changed a lot since 2010. But for that brief period, we got to do a lot of really cool social science with Facebook and published a lot of it. And I just wish I could go back and there was so much more stuff we could have done. And I wish it's not so much a failure, it's a regret that we didn't do more with the time we had.
Is that something that we're also going to run into now with Twitter?
Quite possible.
Like this idea that we think is going to be out there forever, and then it's just like, I'll go back and take a look at it. So it's not really. We're getting closer to the end of the session, so maybe you guys have any questions? We've been talking almost among ourselves for a little bit, so are there any questions that you would like to pose to the panel or overall? Please.
Yeah, I have a specific question. So I'm Jackie. I study computer science and linguistics, and my question, and I'm working on research about misinformation in NLP. And my question is, so how do you identify the misinformation or fake news online from a social science or political science perspective? And how do you think the computation tools could help in this process?
5 minutes?
If I would say something, so if you go on the website of Cassandra, the previous roundtable we ran was exactly on that topic. So you, in addition to what our panelists are going to tell you, you can see what other 4 people have thought about it. So.
I'll just say a little bit. We were coding tweets from the 2016 and 2018 elections, and especially for both years, but especially for 2016 in the United States. And I just happened to know about a lot of particular fake things. Project Veritas was having a bunch of fake things, or a bunch of other fake websites that I just happened to know about. And so when we were labeling the tweets, I checked all the labels, tens of thousands of them, and just didn't acknowledge those as being instances where they were trying to pretend they were actual tweets about things we care about. So easy ones to think about, things that said election's gonna be on Wednesday, that kind of thing. My subjective view was I found them all. Of course, I did not find them all. And so there was a question, we were looking at images, and the question is the image a picture of the actual incident of a long line at a polling place? And so that's great, I see an image. Then I see the same image for apparently 20 different polling places. And are none of them real? Is one of them real? And so that I wasn't able to sort out where the original spot was. I mean, I know a lot about America, but I can't tell exactly, is that the right driveway in the elementary school that's in this town? And you can look up Google Images to try to get pictures of the place and try to, but I really.
Geoguesser people to do that.
Yeah, I wasn't thinking about that at the time, so back in 2017 was doing this kind of stuff. So that's a very crude way, just my personal knowledge. And I'm not involved in systematically trying to do that. I'm sure these two can say much more about trying to systematically do that. I don't know if that's what your research is on, but that's certainly one of the most important issues we have today.
I don't directly do work on mis or disinformation, but it's definitely in the broader space of things I'm interested in. It's interesting because a lot of the work I've seen doesn't necessarily just look at the text and say like, is this fake or not? There is some work that does that. But I've seen other approaches that looks at like information diffusion and how that relates to fake news. So like they will have links from sources that they know are disseminating fake news, and then try to see like what's happening with like people sharing these links on social media, or identifying users who habitually share these links and like considering them to be misinformation spreaders. So I think it is interesting for that especially to consider more of this sort of, I guess, media ties. Like you have different sources, like you have the social media discourse, but then you have like these other links, and then you also have the social network components. And I think kind of bringing all of those together with doing text analysis is really helpful.
It's like the problem of trying to say who's a bot, which you also had to deal with.
Yeah.
Fortunately, there were lists online.
Anyone else?
Lavinia.
I'm a first-year PhD student in the School of Information, and I have a kind of secondary interest in, I guess, like interpretability in NLP. So I was wondering, like, if you guys think that part of the issue with like sort of taking, I guess, like NLP or other ML systems is like the kind of opacity surrounding like the nature of their failures. Like, I know that you quoted someone else saying like, I don't know, the problem is just kind of like, does it work or not? But it seems like potentially like, you know, one thing that could incentivize people to use systems is if there is clarity surrounding like when they fail and like what classes in particular might be problematic. It's like, I don't know.
Yeah, I have a couple of thoughts. So I think one of them is, I think I've started to increasingly see things like machine learning models applied to text, almost like undergrad RAs, who aren't as good as undergrad RAs, but are much more repeatable than undergrad RAs. And so it's just in the same way that it's hard to know why an undergrad labeled a document a particular way. You know, I think at the end of the day, I think I'm much more concerned with the accuracy and like Julia was saying earlier, that the accuracy is uncorrelated, or the errors are uncorrelated with other important things about the document. So like if all the news from one particular country gets miscoded, then that's really bad. But if there's sort of a constant error rate, and I don't know exactly why it's generating the labels it is, that it's relatively good and it's uncorrelated, then that's pretty nice for me. I think as a methodologist, it's nice to have some interpretable models. So like, you know, like there's sort of that phase of mapping the attention in like LSTMs or something to say, you know, here's the passage that's most important in generating the label. And I think as a methodologist, that's useful for me to say, is this particular classifier one that I think is useful for this application? I think related to that though is, I think there's been some work, unless like Katie Keith has some work on propagating the uncertainty from classifiers through the entire pipeline. And so, you know, ultimately, you know, we have a lot of great techniques for handling statistical uncertainty, but there's also upstream measurement uncertainty. And a lot of times that just gets neglected. So we assume that the labels are 0 or 1, and then we move on. But I think it would be really good and help us draw more accurate conclusions to say, well, there's some uncertainty that comes from the labels, and so that should be reflected in, say, like our coefficient estimates in our final regression.
And to build a little bit of what you're saying, failures with all these tools are something we've been talking about, but humans are equally bad at classifying things. It's not that anything that is done by any of us in terms of identifying all these issues is absolutely right or absolutely wrong. And I think that there is a certain bias to see the problem that are generated by these machine tools as worse than what by something that is done manually by human coders may result also in bad data quality or bad analysis. And we don't want to recognize that as much as we should when talking in comparison.
The version of the question, I don't have an answer, but I'm about to implement a solution, which is I've got to do research. I can't wait for a real solution to come along. So we're interested in whether there's stability over time. So we've labeled tens of thousands of tweets from 2016 and from 2018 election periods, and are about to apply those to classify tweets from 2020 and 2022, and going backwards to 2014 and 2012 Twitter data. So in terms of the way the election is administered, success voting, absentee ballots, and all that stuff, and now so the short story is, are those tweets portable? And can we make some small changes, like change the candidates' names in the existing tweets, or do I have to pay the price of labeling more tweets, which I absolutely do not want to do? And so I think it's a version, if I understood exactly how even something as simple as sport vector machines worked, then I would have a predictable way to say this this amount of weight is placed on these tokens I want to change, which shouldn't affect my classification from a human point of view, but I have no idea how the computer's handling these documents, and I don't really know a good way to pull that out of an SVM, or we have some other classifiers like that. So that's an important issue, and I'm going to make a bet and we'll do some tests over the next several months to see if we can learn how I can get away without having to label stuff, because that's going to be months delay if I have, and lots of expense if I have to do that.
All right, well,
Can I make one announcement?
please.
Yes, so Dallas Card, who's here at Michigan, and I have organized a happy hour at 5 for people who are interested in text and NLP and social science and sort of the union of all of those things. So it's today at 5 p.m. at Grizzly Peak, and any of you are welcome to join us.
Yes, so we hope to also see all of you there. I hope that you'll also all thank me, join me.
Thank you.
And all sit up, please, thank you. Chris, Walter, Julia, Andy.
Well, it was